Hey everybody. Today we're continuing our work writing equations of lines, but in this case we are adding the requirement that our new line be either parallel or perpendicular to a given condition. So first of all, let's take a look at these three pictures here. In this first diagram, we have two slopes, and these two lines look parallel, and we look at their slopes. We can just count rise to run. We have a slope of 3/2 and a slope of 3/2. The slopes are exactly the same, and sure enough, that's what we find when we have parallel lines. And that's what we're saying right here. If two lines are parallel, then their slopes are equal. You can see in the second picture, it looks like these lines are not parallel, and if you check the slopes, again, you can look at rise to run, we have a slope of 3/3 as opposed to a slope of 2/3. So clearly they are different. They are not parallel. So yes, slopes that are the same means the lines will be parallel. Here in the third picture, again, these don't look to be parallel either. And if you look at the slopes, we have a slope of 4/2, which reduces to 2/1. So it's a slope of 2. And the other line has a slope of -1/2. So they're clearly different, and clearly they are not parallel. But it looks like these lines are perpendicular, and in fact they are. But what we want to do is not just go by the looks of the diagram. We want to look for the patterns in the numbers. And so there's a particular pattern. Notice one slope is positive and the other slope is negative. One slope is represented as a fraction of 2 on the top and 1 on the bottom, 2/1. And the other slope is upside down. It's 1 on the top and 2 on the bottom. So we have words that describe this pattern. If one is positive and the other is negative, we say they are opposite of each other. So two lines are perpendicular if their slopes are opposite. And because these fractions are upside down from each other, we have the word that describes them as being reciprocals. Right, so opposite refers to the fact that you have different signs. One is a positive slope, one is a negative slope. And reciprocals refers to the fact that your fractions are going to be flipped upside down when you compare the others. I'm just using A and B as a placeholder. So if A is on top on one fraction, then A will be on the bottom on the other fraction. If B is on the bottom, then it will end up here on the top. So let's take a look at an example where we're calculating our slopes. I'm looking at example number 2, and we have two lines, but we don't have a diagram to look at. That means we have to calculate using the slope formula itself. So here's line number 1. This is my setup for slope of line number 1. And this is the setup for my slope of line number 2. So if you have multiple calculations, make sure you label them in this way. So line number 1, we have 1, 0 and 7, 4 as points on those lines. So here's the slope formula. It's y's over x's. We're going to subtract those y coordinates, 4 minus 0, over the x's, 7 minus 1. So when you simplify that, we get 4/6. Now I'll reduce it in a moment, but let's just leave it at 4/6 right now. Here for line number 2, the y coordinates are 9 and 0, so 9 minus 0, and the x coordinates are 3 and 9, so 3 minus 9. This results in 9/6. Now if you stop here, it looks like these slopes are completely different. One's positive, one's negative, but you don't have this idea of the fractions being upside down. Are they reciprocals? Well, it's hard to tell unless you completely reduce them. So I'm just pointing out, always reduce your fractions. 4/6 is even, so we can divide out a factor of 2. That results in 2/3. 9/6 is odd, so we can divide out a factor of 3, which results in 3/2. Now it's easier to determine that we have this pattern of upside down fractions. One fraction is positive, the other is negative. One fraction has 2 on the top and 3 on the bottom. This is the other way around, 3 on the top, 2 on the bottom. So these are opposite reciprocals. So now we know that these are representing lines that are perpendicular. So line 1 is perpendicular to line 2. So that's our introduction to parallel and perpendicular lines. In algebra, you've probably written equations of lines that are parallel. What we're adding today is going to be an example where we have to write equations of lines that are perpendicular. So let's start off with example 3. Well, we're going to write the equation of a line. It's passing through this particular point. But it's going to be parallel to the given line. So this is something that you should have done in your Algebra 1 class. Let's review it here. So this is my old line. This is my existing line. I'll label it as old because it's the previous line. We have to write the equation of a new line. So my old line is what's given to me, and it has a slope of 3. There it is. So I want to figure out what the slope is of my new line. Well, if my new line is going to be parallel, we know parallel lines have to have equal slopes. So we can take that information and apply it to my new line. They have to be equal slopes, so it's also 3. We're told that the point that my new line must pass through is this -2, 3. And that's useful because it provides an x-coordinate and a y-coordinate. So we have a slope. What we don't have is the y-intercept. We don't have what we call the b. The old line had a y-intercept of -5, but my new line will have a different y-intercept. So that's what we have to find using y equals mx plus b. So the y represents the value of the y coordinate here and the point that we're provided, which is 3. The slope is the new slope, which is also 3. The x is representing the x-coordinate of the point that a line is passing through, the -2. And our job is to find the variable b. Let's multiply 3 times -2 is -6. Let's add 6 to both sides so that we can isolate the variable, and my b is equal to 9. So now we have a new slope of 3. We have a new y-intercept of 9. So my equation is y equals 3x plus 9. Now let's just graph these two real quick so that we can see that they really are parallel. You can see they have the same slope of 3. They should be parallel, right? So here's the old line. I'm using a scale of 2 just to help it fit on the graph. Here I have a y-intercept of -5, so going down 1, 2, 3, 4, 5. I'm between the grid lines, but there it is at -5. And with a slope of 3, you can think of that slope as a fraction, rise over run, 3 over 1. So up 3 grid lines and over to the right 1 grid line. So kind of in between grid lines here, but up 1, 2, 3 spaces. To the right 1 space, that's our slope. 1, 2, 3, 1. You can repeat that a couple more times. And that's the path of the old line. And because we're graphing 2 lines, I'm going to label it. This is the line y equals 3x minus 5. My new line has a y-intercept of +9. So 2, 4, 6, 8, 10. So 9 is right here. And with a slope of 3, we're going to go up 1, 2. Well, we're off the grid, so let's reverse the process. Let's go down 3 spaces and to the left 1 space. So down 1, 2, 3, to the left 1. Down 1, 2, 3, to the left 1. And it certainly looks like these are parallel lines. That's the line y equals 3x plus 9. Now remember, we're not trying to solve this just graphically. We need to be able to solve it algebraically like this. But you can see on the graph it confirms our results. So that's something you've done before, like I said, in Algebra 1. What we're doing here in geometry that you have not done in Algebra 1 is writing equations of lines that are going to be perpendicular. And we'll use our next example for that. So here's example 4, where we're going to write the equation of a line passing through this point, 1, 2. But this time our line has to be perpendicular to the given line. So there's the old line. But I want to write a new line. My old line has a slope of -2/3. Because our new line has to be perpendicular, we need to apply the pattern. First you change the sign, so 1 is negative, that means this has to be positive. And then we flip the fraction. So if the old line is 2 over 3, my new line's slope will be 3 over 2. So it's a positive 3/2. It's the opposite sign, and we flip the fraction. Again, the point that we're going through is 1, 2, and that will provide us with an x-coordinate and a y-coordinate. So the only thing we don't have is the value of b. We don't have the y-intercept, and that's what we have to find. So we're using y equals mx plus b again, still the equation of a line. My y value is 2. My slope is positive 3/2. My x coordinate is 1, and we're solving for b. So 3/2 times 1 is just 3/2. I want to review with you fractions. You might be tempted to turn that into a decimal, and yeah, that's easier, but let's review how to combine fractions. So I'm going to move the 3/2 to the other side, so I have to subtract 3/2 for both sides. So it looks a little bit strange. On the left you have a 2, and you're subtracting 3/2, and that will be the value of my y-intercept, b. To do this, remember to set up a fraction. So make that as 2 over 1 minus 3/2. The denominators are not the same. So you might remember that what we need to do is create a common denominator. So I'm going to identify the bigger value, which is the 2. And I want both denominators to have a 2. That means I'm going to multiply the first fraction using that 2. We'll multiply top and bottom by 2. So 2 over 2. So when you multiply those together, you have 2 times 2 is 4, and 2 times 1 is 2. So you have a fraction of 4/2. And then we're subtracting the 3/2. And that will be the value of b. So 4/2 minus 3/2 is 1/2. Right? See how you have the common denominator as always 2, 2, and 2. The only thing that changes is the numerator. 4 minus 3 gives you that numerator of 1. So now we can write the equation of our line with a slope. Now be careful, don't accidentally write using the old slope of the old line. We want the new slope of our new line, which is a positive 3/2 x. And with the y-intercept of 1/2, we have y equals 3/2 x plus 1/2. All right, again, so let me graph this real quick. Here's the old line. We can use a scale of 1s on this graph. The old line has a y-intercept of -3, so we're starting here. With a slope of -2/3, that means we're going to go down 2 and to the right 3 spaces. So that'll be the line. Let me get a couple more points on here. So reversing the process. Instead of going down 2, I'm going to go up 2 and left 3 spaces. So there's my old line. And I'll label that. And my new line has a y-intercept of positive 1/2, so we're right here between the grids. And with a slope of 3/2, we're going to go up 3 spaces and to the right 2. Let me reverse the process so I can work sort of down and to the left here. So down 3 spaces and to the left 2. And here's the new line. And sure enough, they do look to be perpendicular. Again, we're not solving it. We're just not, we're not only solving the problem by graphing it. We're not only going by looks. We are going by the calculations, but this should confirm what we've done with our math here as well. Does this line go through this point, 1, 2? That was a requirement. Here's 1, 2. Yep, it does go through that point. So that's good as well. So let's just review the process real quick with example number 5. Without the graphing component, we're just doing the calculations. We're going to keep the point the same that our new line goes through for these 2 parts. Part A, we want a new line that's parallel to the given line. And in part B, we want a new line to be perpendicular to the given line. Notice in both cases, we're using the same line. They have the same slope of 4. So my new slope must be 4 as well, if my new line must be parallel, as they have to have equal slopes. Again, what we don't know is the y-intercept, because you can't use the old y-intercept. We need a new line, we need a new y-intercept. So we're using y equals mx plus b again, and we're using the point for the x and the y coordinates. So the y is 5. My new slope is 4. The x coordinate is -2, and we're solving for b. And that will give us a result of 13. So my equation of the line is y equals 4x plus 13. Right? Notice that the slopes are the same because they're parallel lines. The y-intercepts are not the same, right? They have to be in different locations. Now, for part B, I want a line that's going to be perpendicular to this given line. So my new line must have a new slope of, now we have to make it the opposite reciprocal. So we want to change the sign from positive to negative, and we want to flip 4 upside down to make that 1 over 4. That's my new slope, and again, we need a new y-intercept. So using y equals mx plus b, again, y is the value of 5. My slope is now negative 1/4. My x-coordinate is the negative 2. I need to solve for b. Simplifying these fractions, we have a negative times negative, which will give me a positive. And when you multiply that together, you have a 2 over 4, which is going to be 1/2. So I'm going to move the 1/2 to the other side. We're going to subtract 1/2 from both sides. So on the left we have 5 minus 1/2 equals b. Once again, we have different denominators, so we have to create a common denominator by multiplying that 5 by 2 over 2. So that means we will have 10 halves minus 1/2, which is 9 halves. So that's my y-intercept. So my final equation is y equals, don't use the old slope, use the new slope, negative 1/4 x, and the new y-intercept of positive 9 halves. So I want you to practice these. I'm providing the answers here so that you can check your own results. You're going to write a new equation passing through the point 4 common negative 1, parallel to this given line. And here's your answer, y equals negative 2x plus 7. See if you can get that result. And then perpendicular to the given line, your answer should be y equals positive 1/2 x minus 3. Jot those down, pause the video, see if you can work those out, and see if you can get those answers. We're going to finish up here with example 6, because this is a bit of an unusual case, in that the form of the equation doesn't look like how we're used to seeing it. We're used to seeing the y equals mx plus b, where you have both x and y. We don't have an x, we just have the y. So if you are only seeing one of the two letters, that means it's one of our special cases. It's either a vertical line or it's a horizontal line. We use this phrase to help us remember how to write those equations. So we call this vux hoi. Vux is V-U-X and hoi is H-O-Y. V stands for a vertical line. Its slope is undefined. And its equation only uses the x. Well, that's not what we're seeing here. A horizontal line has 0 slope and its equation only uses the y. Yeah, that's what we're seeing here. So this is describing a horizontal line. All right, so just picture that for a moment. Here's your x and y axis. And here's your horizontal line through 4. All right, so there's your horizontal line. We want to write a new equation that passes through this point. So again, that provides you with an x-coordinate and a y-coordinate. And we want it to be parallel. So what kind of a line is parallel to a horizontal line? We want another horizontal line. So my new line must also be horizontal. So how do we write the equation of a horizontal line? We use only the y. So we need y equals a number. I can't use 4 because that's the old line. I need a new y value. And that's what the point is going to provide us. Look at the y-coordinate. It's a negative 3. So that's your equation. So there's really no calculation here. You just have to pick up on the pattern of whether we're talking about horizontal or vertical lines, and whether to use the x or the y value of the given point. So here's part B. Our new line has to be perpendicular. So we're using the same given old line of y equals 4. So there's its sketch again. So the old line is horizontal. So the question is, what would be perpendicular to a horizontal line? My new line must be vertical then, because we know vertical lines are perpendicular to horizontal. How do you write the equation of a vertical line? A vertical line has undefined slope and its equation uses only the x. So we're going to have x equals a number. What number should we use? Well, look for the point. There's your x coordinate, which is a 2. And that's the equation of your vertical line.